Hello everyone, welcome to today's lesson. We have already completed quadrant rule and we have started compound angles. I suppose you are already aware of the formulas in compound angles. It gives us some addition and subtraction formulas. So here we have the first sum for today. Prove that sine 105 degree plus cos 105 degree equals to cos 45 degree. This sum is based on compound angles because 105 degree is an angle that we are not aware of. It is not standard angle, but I can make 105 degree by combining two known angles. So let's start this sum from the left hand side. So I have sine 105 degree plus cos 105 degree, and what can I do is I can write 105 as sine 60 plus 45, isn't it everyone? 60 plus 45 is equals to 105, plus cos can also be written as 60 plus 45. So I have used two known angles or standard angle to make 105 degree. That gives me the formula. What is the formula of sine a plus b? Look at the compound angle formula that you have in your notebook. This acts as a and this acts as b. Here this acts as a and b. So I need to write the formula for sine a plus b, and the formula is sine a, that means sine 60, cos b, that is cos 45, plus cos a, that is cos 60, and sine 45. So again I repeat, it looks like sine a cos b plus cos a sine b, plus I have the other side now. Cos 60 plus 45 can be written as cos a cos b minus, remember it goes with a minus, we see the formula properly, sine a sine b. Is that correct everyone? Check this out one more time. There's a formula of sine a plus b and cos a plus b which you are already aware of. So let's put in the values. Sine 60 is equals to root 3 by 2, cos 45 equals to 1 by root 2, plus cos 60 is half again, and then 45 is 1 by root 2. I suppose you are already aware of this standard values. Cos 60 again makes us half, and then 1 by root 2, and that's followed by sine 60 root 3 by 2, and with sine 45 1 by root 2. So now let's simplify this. Before I simplify, I can cancel these two. So I get 1 by 2 root 2 plus 1 by 2 root 2. That's these two values, the other gets cancelled, correct? And finally I have here 2 root 2 as LCM. Can I write that? And then I get 1 plus 1, that gives me 2 by 2 root 2. 2 and 2 gets cancelled. That's equals to, let me write it down here, 1 by root 2 left over. And isn't it equals to cos 45 degree, because 1 by root 2 means cos 45 degree, and that's what I had to prove is equals to cos 45 degree. So hence proved. Okay, the second sum, a rather very interesting sum. It says prove that tan 18 plus tan 27 plus tan 18 dot tan 27 equals to 1. This is a very tricky sum actually. So how do I start with this? There is a very different way of starting it. Instead of doing it from the LHS, what do I do is I start from a known value. If you observe carefully, you see 1827, there's a combination of 1827 everywhere. There's 1827, 1827, and if you add 18 with 27, you are going to get 5 and 45. Isn't that a known angle? So I start this sum with, we know, check this out, we know tan 45 degree equals to 1. I start by saying this. Everyone knows tan 45 is 1, isn't it? But tan 45 can be written as tan 27 plus 18. Can I do that? That's equals to 1. So that gives me now formula. What is the formula of tan a plus b? Let me write it down here. Tan a plus b is actually equals to tan a plus tan b divided by 1 minus tan a tan b. Isn't this the formula, whatever we have discussed earlier? So let's put this formula, tan 27 plus tan 18 degree whole divided by 1 minus tan 27 degree dot tan 18 degree, correct, equals to 1. Time to cross multiply. Can I do that? Tan 27 plus tan 18 degree equals to 1 minus tan 27 degree tan 18 degree. So now finally let me transpose tan 27 degree plus tan 18 degree plus tan 27 degree tan 18 degree is equals to 1, and that's what I had to prove. Check this out, the blue highlighted statement exactly equals to the one I have here, so you can write hence proved. The third one, prove that cos 15 plus sin 15 divided by cos 15 minus sin 15 equals to root 3. So when we have a fractional formula like this, fractional trigonometric term, I can convert it to tan, because in terms of sine and cos I don't have any such formula, though there is a direct formula. But let me start by copying the LHS first of all. Cos 15 degree plus sine 15 degree divided by cos 15 degree minus sine 15 degree. Okay, you may say there is already a formula in terms of cos and sine. That's the formula of tan 45 plus theta, isn't it? Tan 45 plus theta is actually equals to 1 plus tan theta divided by 1 minus tan theta, if you check the formula. And that can also be written as cos theta plus sine theta divided by cos theta minus sine theta. I could have done that, isn't it, everyone? Yes, but I won't use this directly, so rather I'll convert this to tan and then back to this. Okay, so how to do that? In order to convert this term to tan, what will I have to do is I'll have to divide it by a particular trigonometric expression. So I will divide by rather cos, so dividing both sides by cos 15. If I do that, I get cos 15 degree plus sine 15 degree divided by cos 15 degree here, and in the new denominator as well, cos 15 degree minus sine 15 degree divided by I have cos 15 degree. I need to divide both the not both sides, my mistake here. I need to write dividing numerator and denominator by cos 15, correct? That way now what will happen, let me distribute it. I'll get cos 15 divided by cos 15, because the LCM gets distributed, it goes here as well as here. Same thing will happen here as well, so plus sine 15 degree cos 15 degree, and ultimately I have here cos 15 degree divided by cos 15 degree minus sine 15 degree divided by cos 15 degree. So here I can cancel these two, and finally I land in, what do I get here is 1 plus tan 15 degree divided by 1 minus tan 15 degree, because sine by cos is tan, sine by cos is tan. So this can be written as now tan 45 plus theta, and here theta is 15, so that's 15, and that gives me tan 60 degree, and everyone knows the value of tan 60 is root 3. So hence proved. Here we have the next sum, and this can be a little trickier than the previous one. It says prove that tan 45 plus a plus tan 45 minus a divided by tan 45 plus a minus tan 45 minus a equals to cosec of twice of a. So you have to make it cosec 2a ultimately. So what do I do is, let me start by saying these terms will be quite difficult to handle, to write again and again. So let me temporarily let pi by 4 plus a be equals to, let's say, alpha, and pi by 4 minus a temporarily be equals to beta. That way it's easier to handle the sum. So I have the LHS. The LHS becomes tan alpha plus tan beta divided by tan alpha minus tan beta. That's temporarily for some time, correct? Let me convert this to sine cos. Why? Because ultimately it's in terms of cosec, so I'll have to convert. So that will give me sine alpha cos alpha, you know the formula. Then comes sine beta cos beta, because tan means sine by cos. Here comes sine alpha cos alpha, tan alpha equals to sine by cos, and here I have sine beta by cos beta, correct? Let's take LCM. Let me do it here itself. That gives me the LCM is cos alpha cos beta in the numerator and similarly in the denominator as well I have cos alpha, cos beta. So that gives me here sine alpha is already present there. From here cos beta goes up, so we'll get cos beta plus sine beta cos alpha, correct? How come? Let's see. Because for the LCM it needs to be divided by the denominator. When I divide the LCM, this one, by cos alpha, cos beta is the remainder, and then cos beta moves up and multiplies with sine alpha. Same thing goes to the other side. Okay, so here I have sine alpha along with cos beta minus cos alpha along with sine beta. So that can be done, because the uncommon one goes up, by the way, because if you see here, cos and cos gets cancelled, cos beta moves up and goes with sine alpha. So let's cancel this, and I'm left with now, let me do it right here, sine alpha cos beta plus cos alpha sine beta. Rearranging that, sine alpha cos beta minus cos alpha sine beta. Sounds familiar, isn't it? So isn't this the formula of sine a plus b, and this is the formula of sine a minus b? So can I write it sine alpha plus beta and divided by sine alpha minus beta? Done. But now let's replace alpha and beta, correct? Okay, so that's taking too much of space, so let me do it here. Now let me replace. So sine alpha means 45 plus a, by the way, plus 45 minus a, and below sine 45 plus a minus 45 plus a, because minus into minus becomes plus ultimately, correct? Replacing beta. Okay, then let's cancel. A and a gets cancelled, pi by 4 gets cancelled. That gives me sine pi by 2, isn't it? Pi by 4 means 45 plus 45, that's 90, and that's pi by 2 divided by, that gives me sine 2a, but sine 90 is 1 and you have sine 2a, and ultimately when you flip, this becomes cosec 2a, because sine cosec is the reciprocal of sine. So I can write here, hence proof.